Testing. I think we should be live. I should go back to this first slide. Oops, I forgot to update image here. And if you're joining in already, say hello in the chat. Forgot to update a link in the first part too. Let me just do that real quick for you all. So we can go to make sure we go to the right places today. I'll make this look better later. All right, so people joining in, I'll share this when we get to the code part as well. I just have a few slides I'm going to go through to set up the tools that we're using, or talk about the tools that we're using, and the talk about the tools and a little bit about planner agents, or sorry, research agents. But as you can see, I did not update that part here. All right. All right, let me just get situated here. I'm making sure that we are live in all the right places too. So if you can hear or see me, it's always good to double check in the chat. Looks like my audio is working, but always good to double check. I see people joining in. Say hello in the chat, everyone. And while you're joining here, again, let me just pull up the stream to make sure it's working and make sure I can share the links with everybody. So if you're watching this on YouTube, you should have getting in feedback. All right, the link should be in the description as well, but I'm sharing it in the chat right here. So this is the code that we're going to run. Like I'd mentioned, I'm going to go through some slides first, kind of just set up the premise of what we're going to build today, which is going to be a research agent, and we're going to use Tavily, LangGraph, and Flyte 2. You can go to that GitHub. I know, like when I'm at a talk, I like poking around at the code right away. So you're welcome to do that. And then I'll go through setup and stuff as we go. Should be pretty easy to install if you're going to run this locally. But I also recommend running in code spaces if you don't have like UV setup or anything like that. You don't want to mess around with a local environment. You can use GitHub code spaces, which you'll see there's a link here. Again, I'll go through this when we actually get running. But you can go to click on this and I'll open up the repo inside of a code space. And then you'll, which is a kind of like a full VS Code with an environment that it's running on inside GitHub. And I think that if you have a GitHub account, you get, don't quote me for sure, but something like 120 hours for free on just their kind of low tier, which is all we need to run our agents today. And again, just making sure I can share this link in one more place real quick. All right. I haven't seen anyone say hello in chat yet, but I see quite a few people joined in. So again, welcome. It's possible the chat section isn't rendering for me yet as well. I'm just going to say hello in there. All right. So yeah, so if anyone's here, say hello and maybe put where you're watching from and why you're interested in building agents, or if you're already building agents, let me know. I'm going to wait one more minute before we really get going. All right, let's go through part of the slides. Again, I shared the link. I'll share it again and go through the setup when we get there. Quick introduction. My name is Sage Ellett. I'm an AI engineer here at Union AI, and we also build Flyte, which is I'll talk more about this, but it's a popular open source AI orchestration tool. You can connect with me on LinkedIn if you have questions later. I'm also in the Flyte Slack. Either if you have questions later, like after this workshop, the best place to contact me is either LinkedIn or the Flyte Slack, which I'll share here in a minute. Someone says they're watching from Palo Alto, Los Angeles, Italy. What time is it in Italy? It's always fun seeing people all over the world tune in. I'm streaming from Seattle, Washington in the US. So again, people have already started talking in the chat now, which is awesome. It makes it way more fun for me seeing that there is people here that are talking. So say hello in the chat. again, put where you're watching from, maybe what you're building or why you're interested in agents. Like, have you already built agents before? Have you done any, have you used any frameworks or different tools that you like? And then if you want to kind of join our community where you can have more permanent conversations and more permanent introductions, you can go to the Flyte Slack channel. So as I mentioned, Flyte is our open source AI orchestration tool. We're going to be using part of that today in our workshop, as well as some other tools. So I'm going to introduce those just after I get through kind of the introductions that people are putting in the chat. This is 9 p.m. in Italy. Well, awesome. Thanks for taking your night or evening to tune in. Mike is also watching from Seattle, and they want to see a little bit about what agentic building can do for your AI consulting. Awesome. Yeah. I mean, I'm sure, you've been reading about agents, if not building them yourself, and you can do all sorts of stuff with them. So we're just going to kind of scratch the surface today on building our kind of own little research agents, as well as basically making production grade like workflows. And what we're going to do is build an agent that does kind of a little research thing. So it's going to take a task or a query. It's going to plan out how to search. And then it's going to we're just going to build one search tool today, but I'll show you, like, we're going to define a tool. You'll learn how to define your own tools. So you can kind of take what you learned here and then build out different tools with different search methodologies if you want. So we're going to use Tavily today. I'll talk about them briefly and we'll see it in action, but there's other search tools if you want to check them out as well. And then, so it basically plans like search, and then it's going to do a search based on the parameters are passed in. So we'll see this in action here. And then most of the time when you have like a research agent, it's going to kind of review that data and maybe make a decision of, should it search again? Should it get more data? You can pass in parameters like always do 2 searches on subtopics, like breakout. Like, I'm going to give it one topic. It's going to come with several subtopics, then do search on them, and then might review the data and then make a decision of, like, should it search again? Should it go ahead and pass that data through? And then in the one we're going to do today, we're going to like generate a report from that. You can go read more about like deep research agents. This is kind of a very, very lightweight version that we're going to build today. That's pretty simple, but it gives you kind of all the groundwork for taking this and doing more complex things with it. And again, we'll be building this with LangGraph. Has anyone used LangGraph before? So let me open up my LaCroix while I'm asking that question. If you haven't used LangGraph, I'd be curious to also hear, have you used a different agent framework, or have you just been building stuff from scratch without a framework? LangGraph, you can go check it out here. They're probably, just from my perception, I don't have data on it, but they're probably one of the most used framework in terms of like giving you a Python API that abstracts a lot of the agent methodologies out. They're probably the ones that I've seen kind of the most that people are using right now. Someone said they're currently working with LangGraph, still learning about it. Awesome. They have also some like pre-built agents, so like a React agent and stuff. We're going to actually go ahead and implement kind of our own React agent just using their kind of graphs, which we'll see in action here. So you'll hopefully learn a little bit about how to like build your own agents here in LangGraph. But you can also dive deeper and use like more pre-built stuff from them. But even from doing it kind of from scratch with LangGraph, hopefully you'll see it's not super, super complex. And then we're going to use Tavily. Has anyone used Tavily before? And I'll note, so there's going to be kind of 2 parts to this workshop if you're following along. So we're going to run everything locally or in GitHub code spaces, but that just means like it's going to use your local environment variables. So if you want to run everything locally with me kind of as we go along in the code, you're going to want to create a Tavily account. It's free. You get quite a bit of like, I forget what they call it, not tokens, but basically the amount of search queries you can do. You get quite a bit for free. So if you want to follow along, go ahead and create an account there and create an API key. And I can go through that a little bit later when we get to that point of the code, but just calling that out, that's probably the one account that you'll want to go ahead and create if you want to follow along locally. But when we get to the point of, after I go through locally, we're going to deploy this up to like a Flyte cluster. I have already added people that did RCP on Luma into the cluster, and I've put remote keys in there already. So if you don't want to create the account right now, You can wait to that remote part and you should still be able to run the agent. Oh, also, we're going to be using OpenAI for our LM today. That's going to be controlling our agent. So you should have a OpenAI account as well if you want to run the local part. Again, if you want to wait to the remote part, you should be able to run that. But just calling it out now, you'll need a local Tavily API key and a OpenAI API key. And then we're going to be using Flyte 2. People here might have heard of Flyte. Flyte originally came out of Lyft. That's why it's spelled that way. And then we maintain it at Union. So Flyte is an open source AI orchestration tool, and Union's built on top of it. 2.0 is new, and it's not in full release yet, but it will be soon for general availability in the next month or two. But the SDK is out, and actually you'll see today you can do a lot with the SDK just for building stuff locally. Hopefully you're going to like it. It's actually going to be the first time I'm going to show it in the workshop because we had some really cool new features come out where you get like a terminal user interface. It's awesome for building agents. We're going to dive into that. You can also use 2.0 today on Union. And with that, we'll see this all in action, but you get task level compute. So if you're having agents where you actually want to load in custom small language models and you want to have GPUs for that, basically you can create these environments where you add in just with a snippet of code, the compute that you want, like GPUs, CPUs, etc. That's not all handled in Flyte. You get retries and durability out of the box. So if your API search API fail, if your search API call like fails, it'll automatically retry it. You can also do things like automatically overwrite your infrastructure that the agent's running on. So if it gets like an out of memory error, you can actually change that because again, it's all defined in code here, which we'll see in a minute. Everything's containerized. Also, you can define those containers in Python so you're not writing Docker files, and then it'll check to see if that container already exists. And then if it doesn't, it'll build it for you. As caching, we'll see a little example of this today. I've actually found that caching is really cool for building agents. So if you're doing like long agent runs like you kind of see here, and you just want to edit this last agent part, once it gets all that data, you can cache all these previous results and then just work on the other part. This is actually just really good for debugging. There's obviously other use cases like for planning. Actually, we'll see it today. Like for our planning, if you get the same query, maybe you don't want to rerun that part again, you can use caching. So if you're doing really complex like planning sessions where you don't want to rerun that compute, the caching is good for it too. We'll see reports and actions where we can actually just look at the HTML or Markdown files directly in the platform or locally as well. So it's a local feature in the SDK. We get traces and a whole bunch more. We'll see a lot of this in action as well as app serving. So we're going to build our agent that's going to do research, but we'll also build a Gradio interface for it that we can serve locally and then also serve remotely as well. I think I'll just go through and show the code directly now if everyone's ready. I think people are here. People are probably ready to start writing code if you haven't already. I was just going to show real quick. So we'll see this in action, but you create your environment, you pass in secrets, which here we're using actually these ones, the OpenAI and Tavily secrets. These are what I added to the remote cluster. Again, you only need to set them up locally if you want to run locally. And then here we just define the compute when we deploy remotely, CPU, how much memory, and then if you want a GPU or not. So again, really easy to switch between different models or load in your own models here right on a Flyte cluster. Is everyone ready to run some code or watch me run some code? Let me know. Again, here's the link that we're going to be using. And I'm going to go and try and run this through code spaces because I know a lot of times people don't always want to set up like their own local environment right now. So let's see how this works. I've only done minimal testing on it. If I run into errors here, it should work. And this is the Python SDK for Flyte 2. If you want to go take a look at that. All right. So this is the link that I just shared out. So we're in this research agent workshop section. We're under this whole workshop folder. And what I want to do is running this in code spaces. It should be really quick for us to set up. Again, you could set this up locally if you want to. There's a little setup section here. Actually, I think this might be an older version. Yeah, there's a little section here. So this top part, I think I need to edit this slightly. This is what we're going to do for code spaces. If you're running this locally, you just need to clone the repo and then just change directory into this kind of workshop folder that we're going to be running in, and then just run the uv pip install requirements.txt. Let's go ahead and do this in code spaces though. I'm going to open this in a new tab. So I'm hitting command, click on there. And then this should open a code spaces like this. Like I was saying, if you have a GitHub account, you get quite a bit of hours for free on this for their minimal compute plan, which is all we need. And mine's loading. And if you want, it's kind of easy. Like if you just have that GitHub open off to the side or in another tab, you can go back and forth between these. You can obviously render that in here. So if I go to tutorials, I go into LangGraph, and then I need to delete these. So I apologize. I actually thought I did, but I guess I didn't merge the branch. If you just go into this agent research folder, this is going to contain everything that we're going to be looking at, not the stuff right outside of the folder. So then there's this README in here. If I click there, and then in code spaces or VS Code, you can always hit Command or Control Shift V, and you'll get a view of it in here. But if you're following along, it might be useful. You could just keep this up, this README up in GitHub, and then go through here as well. So again, we're going to build a, well, it's kind of a multi-agent, but it's not a whole bunch of multi-sub-agents. Like if you were at the last workshop I did, we had actually like specialized agents that did separate things. We are going to spin up multiple agents and see how we can spin them up at scale using Flyte. So every time an agent spins up, it's going to be running in its own container. And it can just handle that fan out of like no matter how many research agents you want to spin up. So today we're not going to spin up a ton at the same time, but you could do something like if you're doing a complex research agent, you want hundreds of things spun up at the same time. Flyte can handle that pretty easily. And again, we'll see an example of that here. So we're going to do, we'll look at the code here in a second, but again, it'll do this kind of plan research from the query that we give it. And it's going to break that down being like, what are the subtopics I should search for around this? So if you say like research quantum physics, it'll break out several topics, come up with those from the LM is going to do that. And then it's going to call the search tool. And we can see this is where kind of that parallel Flyte task comes in. So again, we can have like 20 or 100 or more of these types of things running in parallel. So it's not waiting for one research to be done and then goes to the next one. It's doing these all at the same time. And then it's going to pull in all that data and then synthesize the report and then give us a final report that we can look at, which is going to be in like an HTML format for us today. Each of the research topics runs a LangGraph agent, and it's going to loop through, do that search. So if you remember that graphic I showed kind of at the beginning here, so I'll pull it up again. It's going to run through. It's going to do that plan. It's going to do a search. It's going to review the. It's going to reason about what it should do. Do the search cycles using Tavily, and then it's going to put all that in a report. I feel like I'm missing something I was going to say here. I got thrown off. Oh yeah. Okay. So if you're not familiar with React, which is like reasoning plus action, and I should link to the paper here, you could Google it. It's one of the most common types of agents probably right now that's implemented in like coding and a lot of other places where it reasons on something like that request or a sub request, and then it takes an action and then it looks at the result and then it decides what to do next. So it can have like a plan. It can look at the results and decide like, do I need to search again in this case? Is this enough data? Can I go ahead and end the search and then just pass on the data? But React agents are kind of one of the probably more common loops where it does something, reviews it, does something, reviews it, does something, reviews it until it meets that end state. And LangGraph does have a pre-built kind of create React agent class that you can call in, but we're going to build ours kind of from scratch using LangGraph. So you can kind of see a little bit more how the LangGraph API works. Project structure. All right, so my code space is spun up. And if you're running this locally, it should be pretty easy to, again, also install everything. If you're running locally and you already have UV installed, you don't need this first line because this installs UV. And also, we only need this keyring alt thing right now for some of the headless environments. So like code spaces need this. But if you're running this on a Mac or Windows, it should automatically handle storing your authentication with a keyring that's already installed. And if you don't install this here, it's just going to ask for us to auth every time. So I'm going to copy this whole thing because I'm running code spaces. Let me zoom in a little bit too, if this is better for people. So I'm going to go back to my code space. I'm just going to copy this all in. It might ask you, is it okay if I paste everything in? Hit yes. And then let's go. And this should only take a few seconds. UV is awesome. Is everyone using UV already for your Python package management and environment management? All right, so mine's already done setting up. And if everything went smoothly, this should really be the last UV step that we have, or sorry, last setup step that we have to do before we can start running our code. So I'm also just going to hit Command K. That clears my terminal. And let's go back and look over here. All right, so one last thing is actually, sorry, I lied. There was one more setup step that I forgot. So if you are running this locally with me and you want to follow along here, you also want to create a .env file or export these local variables. I'm going to do a .env. And this is where I can store my local API keys. So I have a Tavily one and an OpenAI one. Again, these are going to be put in the remote part. But if you want to follow along with this local step, you'll have to get your own API keys here. I'll just hit save. And then that should be the last setup step before we can run our agent. So I think I'll run the agent and then we'll walk through the code if that works with everyone. So we could run our agent and it's going to go ahead and do that search like we had talked about. And we could pass in like the number of topics that the agent's going to look for based on like the subtopics. So that would be like, again, quantum physics is going to break out 2 separate topics under that and then search for those. And then the max searches per topic. But let's go ahead and run this. And this will give you time to kind of still get set up if you're still doing that. And then we'll walk through the code. So this is me running locally here with the TUI that I mentioned at the beginning, the terminal user interface. That's really awesome for building agents here and other pipelines as well. I'm going to say a Flyte run -- local. So this is going to just run it locally here. It's not going to kick off, try to connect to a remote cluster yet. And then we're passing in the TUI command. And then we're calling workflow.py, which again, I'll walk through the code, but this is where our workflow is. And then we are passing a query here, which is compare quantum computing approaches, superconducting versus trapped ion and photonic. So we'll hit enter. And we should get this really cool interface that should pop up here in a second. So instead of just looking at logs, we get this terminal interface that's really awesome, especially if you're doing something that's more than like 4 agents running at the same time or something like that. You can now see that we have this planning step. And this little symbol means that it wrote to cache, which we'll see that code here in a second. We get this planning step. And then if we click in or navigate with our keyboard into any of these, we get on the right side here a report that was generated. We'll talk about this in a minute, or we'll see what this looks like. And then we get the inputs. So like, what were the inputs to our agent task here in this case? So we can see the query. And then the outputs aren't final yet because it's still running here, but we'll get all the outputs logged here as well. So you can navigate down and click into one of these. So again, we'll see the code here. This will probably make more sense when we look at the code. We have our planning step. Then we have this research topic. And this is where LangGraph starts running an agent. So we can see the inputs to this and the outputs. If we click into this is basically part of the graph where in LangGraph, you have these edges or edge cases, I think is what they call them for the graph, basically saying at a node, there's different steps you could take. What is that step going to be? In this case, should continue as one of them. And we can see that it said we should continue because the agent basically outputted something that told it to do a tool call. And we'll see what that looks like in the code here. But then we look at this web search. This was a tool call. And we can see that this is the input. So this is what it came up for one of the topics to look at. And then this is the output from Tavily doing search. And then it does that all through 3 web searches. And then it calls that agent again. And then if we look at what should continue be. So these are traces on LangGraph. This is the input for everything. But this is the important part. So the output here is basically saying end. And we'll see what this looks like. But that edge node or that use case or edge case in the node is saying it's time to end now. We kind of did all the research and our whole plan. Let's stop that React loop that we were doing. And we can see that does that with 3 different agents here that all ran parallel. We can see this one actually did more searches. That's part of that React loop of like looking at the data and then doing the amount of searches that you think is a good amount. And then at the end here, we have this whole report, and there's a lot of text in here, so it looks kind of maybe kind of crazy in the terminal. Oh, this is going to be interesting actually. So the report, when you run this locally, generates an HTML file. And I did not test this actually in the VS Code spaces or GitHub code spaces. So this was a HTML file. I'm not sure how I can copy this path in and open it directly in here, but this would render a report. We'll see what this report looks like. Actually, I'll bring it up in the Flyte UI. Oh, this is what the LangGraph looks like. If I go to the synthesize report section, this is the report we have. Like I said, this actually renders locally too. When we ran it locally, like with that TUI, it gave us the file location for it. But because I'm in like the VS Code spaces, I'm not sure how to open that file from that URL. This is the final report after the searches that it did here. And then we have these different pages. So these are the 3 subcategories that it decided to do. So you can see research topic, research topic, research topic. These are the topics it came up with to do research. If we click in, we could report from all of those. So it did, like this first one, did 2 web searches, and then it combined those into a report here. And that's what this is. And then the main one synthesized all the reports together. So this is kind of a whole little mini, again, not a deep research thing. Deep research does a little bit more. But this is kind of the start to that, where you could be building your own research agents or deep research agents. All right, so I'm going to go through maybe some of the code here. But is anyone following along, and did it work so far? Let me know in the chat. If it didn't, or no one lets me know anything in the chat, I'll just go into the code next. Also, what do you think of this TUI, this terminal user interface for something like building agents? I think it's really cool, especially when you're doing a ton of tool calls or a ton of sub agents. So again, like you can log everything out, but if you're doing agents in parallel and you have quite a few of them running, it's really hard to see what's going on. And it's kind of hard to debug sometimes when one goes wrong. So in this case, these all succeeded. They have the green check mark. But if something went wrong, see if I can zoom in here, actually, get rid of this AI panel. If something did go wrong here, then you'd get a little red X. So it's really, really nice to get insights, like if an API call failed or something like that, it'll show up here. And then you can very quickly, easily go debug exactly what happened. You also get logs for each of these as well in here. So if you are logging and you want more information that way, I don't think I'm outputting anything in, actually, maybe any of these right now. Do I log anything? Maybe here. No, the log, if you're logging something, they'll show up here as well. I don't think I did that in this demo. I'm just storing the inputs and outputs here instead. So said the TUI is cute, and examples of debugging would be helpful to see because I need to use Bedrock. Got it. Yeah, so if you're doing like local development and testing like a large agent run, this is really useful. I had mentioned too, so we'll see it in the code here in a second, but this says like it wrote to cache. So if you're doing local development, it's also kind of nice to, like I was saying, if you were working on this last one, like synthesize reports, and you want to have that data there, but you want to do the full agent run, you could cache all the results just for your development phase and kind of debug it that way. That's really useful, something I've used quite a bit. And then if you want to also look at all your previous runs, so we only did one here, you could say Flyte start TUI. And we only have one here so far, but a whole list would show up there, and you can click in or navigate in that way. So this also works for kind of like doing like lightweight experiment management too. So not just for agents, but for any pipeline. Like you can log out your hyperparameters, you can log out reports with like your accuracy and loss for your runs, all kind of logged in here. And like I was saying, you can actually usually click and open this on like a local machine and get that HTML report, which is really nice. And you can do any markdown HTML, including more complex charts and stuff like from Plotly. All right, so let's go look at our code. And then, like I mentioned, we'll also deploy this in a Gradio app. So we'll give our agent an interface that we can actually interact with as well. So first, we look at this config file. this is where I set up kind of that Flyte environment that we talked about for, briefly. Again, this is more important when we get to the remote stage, actually. So I'll just briefly touch on it here. But you do need to create basically a minimal task environment, which doesn't need to have all this input to start getting the logging in the TUI, because that's how we structure like inputs and outputs. But for the future part where we get to deploying, this is going to create a Debian-based container. And these are the packages that we're going to pass in. You can also read from requirements.txt or UV script here. These are the secrets we're setting. These are set up again as the remote part. So it's going to read in this API key from with this variable, and then read it into the environment as this local variable. And then we're declaring the amount of compute that we want, which is just 2 CPUs, 2 gigabytes of memory here. And then we're going to use something called reuse policy. So the container is actually going to stay hot. And we can reuse that container so it doesn't have to spin up every single time between all of our agents. So it makes running agents incredibly fast, as well as other types of pipelines. And then next, let's look at the graph part. So this is the LangChain graph section. So again, we're doing tool calling here. This is kind of like I was saying, like a little bit of a manual or hand-built React, the reasoning plus act loop built into the LangGraph state graph. I always get LangChain and LangGraph mixed up. I mean, because LangGraph is the agent framework from LangChain, but I kept almost saying LangChain there. And then again, like I mentioned, they have some pre-built agents too. So if you wanted to make this even simpler using LangGraph, you could, but we're going to go ahead and look at implementing that graph kind of manually here. So it's going to do the agent. It's going to say, do I need to do tool calls? If so, it's going to do the tool call, and then it's going to go back to the agent and do that as a loop. And then when it decides it reaches that end state, it's going to pass that end variable that we saw. So it's going to import some libraries, a few things from LangGraph, and from our tools folder, we're going to import create search tool. And actually, we could look at that real quick if we want. So I have it in a folder. We just have one tool here, but you could add more tools here. We're just initializing our Tavily API client with our API key. This at tool part is a part of LangGraph, so it knows how to do the tool calls once we pass this into the LLM. And this is a super simple tool here. We're just logging what the search was for with the query. We're just go ahead and doing that query, and it's going to look at 3 results, but you can update this to however many you want. Tavily is really cool. They also have a lot of other features than just their simple search query that we're using today. So I definitely check them out if you're looking to kind of get more information from the web. I think they do crawling and stuff like that too. So if you're actually looking to not just do like a quick search query, but actually, I think, crawl some pages and stuff, that's something they could do as well. And then we're going to go ahead and just return the results that we get back out of this tool. So pretty simple tool. Main thing is this tool is part of LangGraph. It's going to make it easy for the LLM or LangGraph to call it. And then we add Flyte trace. This allows us to see, like in the UI or even locally in that TUI, we can see that this is a trace of any function that's running inside of a task. So we added it to our agent and the state, and that's how we're seeing like should continue. Was there a tool call? And then this is the actual tool call here, the web search. So you don't have to do it on this agent state if you don't want to, but it's kind of helpful, at least for debugging, to see what was the output from the agent and what was that should continue state. Like we get tools there. If we look at should continue at that last one, we get end. So if you're looking, trying to kind of debug like what's going on with your LangGraph graph, having this trace on that is pretty nifty. Let's go back to the graph.py. So we scroll down, making sure I'm in the right one. Yeah. So now we're going to start implementing our agent here. Again, we have this function build research graph. It's going to take an open API key, Tavily API key. Max researches, the default is 3, a model string. So you could update this to be a different model. Again, we're using OpenAI here, but you could also switch this out for like Claude or anything else that you want. Also, quick question, actually, what are people using? If you're building agents, what model are you using or API are you using? Are you using something like OpenAI, Claude, something else? For these tutorials, actually, too, are you using other libraries like LiteLM that are a wrap around those things that make it easier to switch? I was thinking about that the other day. I was like, oh, maybe I should start building the tutorials with Light LM and make it easier for people to switch to different APIs. So quick question for the audience. What APIs are you currently using right now for building or experimenting with agents? And while you're thinking about that, I'll just go ahead and keep going down. So first part is we're going to set up the tools and the LM. We're just setting up that tool that we had created. We're going to pass it into a list here. In this case, we just have one tool, but you could add more tools and then put it into this list. And this is going to go into our prompt, so it knows what tools it can call. Or sorry, not going to go in our prompt because we're using LangGraph. Normally, if you're doing this from scratch, you could pass that list into your prompt. LangGraph will automatically do it where you just call this .bind tools on it. We're initializing our LM with the chat OpenAI. This is something built in a LangGraph here. So we're passing the model, API key, and then we're saying bind tools. And now it's going to know how to do tool calls to the tools that we passed in. Someone said they're using Claude, which makes sense. I use Claude Code all the time right now. For some reason in my tutorials, I'm still using OpenAI. I go back and forth of what I want to use. So I think, has anyone used something like Light LM or a different wrapper? Or do you just always use like the whatever convention from your API? And then this is our system prompt for our agent. So you could edit this to be way more robust. Or if you're doing like a specific search agent for specific topics, you might want to edit this. So again, we're just kind of doing a general lightweight research agent today, but you could really go and customize this a lot to do whatever you want. So our system prompt here is just saying you're a research agent. Your job is to thoroughly research a topic by searching the web. Use the web search tool up to, and then that max value gets pushed into that prompt, times to gather information from different angles. After gathering enough information, write clear research summary with key findings and sources. And then we define our agent node. This is the reasoning step of that React part. So the LM sees the full message history and decides to either call a tool or return the final answer. So that's when it decides, am I doing tool calling or am I going to say final? And then we're going to kind of just break out of this graph cycle. So we're defining our agent message state. This is something from LangChain. So again, or LangGraph. So you'll see the state of the previous messages here. And then it's going to look at the message and basically decide again to do a tool call or not. So we're going to be looking to see, does the output have tool calls? If so, then we're going to go ahead and pass it on to call the tool. And then we have our defining the routing function. So this is the actual routing part for the tool calls. Again, this has Flyte trace on it. So that's how we can see all these different steps, like the agent state tool call, or this is the agent state of the actual tool call. Since this should continue, and the output's going to be a string, and it's going to get that last message. Again, this is where it said like should continue or end, or do the tool call and then return the tools. And then this is going to build the graph. So we just have those two nodes here, the agent and tool execution node. And like we had seen, they're just going to kind of go in a loop until it gets no tool calls, and then it's going to end. So in LangGraph, you do this by initializing state graph, pass in that message state. We're adding the nodes here, the agent and tool node, which we had defined. And then we're setting the entry point, which is going to be that first one, the agent piece. So it's always going to call agent first, which is going to give it this prompt as well. And then it's going to start reasoning about what to do. And then it has this other tool node in there. So if you have a more complex agent, today's, I actually render this out in a graph here. So super, super simple kind of reasoning plus reaction agent, or action plus reasoning agent. So our agents are going to go, it's going to be calling tools until it thinks it's done based on its reasoning, and then call the end state. It's going to do that for all the different research agents. But if you're doing a more complex agent, then you can add way more nodes here, and like a different entry state, and then different types of tools or different sub agents that it could call. And then again, just looking at tools and the end state here. And that's our graph. It gets compiled. And then let's go look at our workflow, which calls this graph. So this is the kind of, and you're saying multi-agent here, where it's spinning up the same agent multiple times and then fans it out and parallel for researchers, and then synthesizes. The architecture, you have that planning task, the researchers, and the synthesizer. So each task shows up separately in the Flyte UI, like we saw in the TUI, but also on the remote UI. And we saw how we can run this with a TUI, and then we'll show how to run this remotely here in a second. You just import some things you've probably already seen before. Flyte logging. Flyte can use async IO, so you can program like you normally would with async IO in Python, and then it'll automatically, when you do like async IO gather, that's how it will do the fan out in the remote cluster. So you don't have to do anything special or think about anything special. Like Flyte 2 is pure Python with async, and then it handles all that for you really easily. And we have a quick little function that just converts Markdown to HTML. That's how we're going to build our reports today. And then we have our first tasks. So this is the Flyte task now, and then we're going to give it either pass in like our LangGraph agent, or give it basically wrap anything that you want to show up in the UI and run on compute under this task. So you can think of this as a unit of execution. And we're saying report is equal to true, so we can render that report, the HTML report, and then cache is equal to auto for this first one. So if we do the same search query multiple times, it'll actually cache this task, and it doesn't have to rerun it unless it gets a different search query, because in this case, it's just planning. So we'll still do the new search because maybe new information came out, but it's going to cache it and say, I already know the topics, in this case, the subtopics that I broke out, and I'm just going to go do search for those again, but I don't have to do that planning state again. And if we had a more complex planning thing with a lot of reasoning, this could save you a lot of tokens and potentially cost over time. So we're going to initialize our chat again and say, break this research question into number of topics. Again, by default, it's 3. Focus on subtopics. We're saying return only JSON array of strings here, nothing else. So we're going to get the JSON return. I think if you're doing this production too, you might want to look and make sure that you're using like an output parser, either one that's built into LangChain or something like BAML or Instructor. But it should work good for our pretty simple use case today. Then we're going to try those topics, and we're going to import the research into our plan here. Or sorry, this is going to create a tab, I think, for our plan here. And then we will put the query in, and then when we get something returned, we'll update the HTML report with that. So here we're now researching a single subtopic. We're defining the research topic, and then it runs the LangGraph research graph on a single subtopic. So this is that thing that we had defined, that basically now we're using that LangGraph React agent. And it's just going to get that topic and call it, and then put these in the report. And then the last one is just synthesize the report. So we're just saying that it's a you have a research report on subtopics of this question. That's the query. And then it gives all the information in there. And then it's going to synthesize that final report that we saw. And then it's going to return that as an HTML report as well. And then this is our research workflow. So the tasks in Flyte and Union. If you used Flyte v1, you might remember that you had tasks, and then you had a workflow decorator that you would define all those tasks in. In 2, you just have tasks, and tasks can call other tasks. So here we're telling it how to call these. So we're going to call that, well, first we're going to build the research graph, but then we're going to go ahead and call the plan research, and then the plan research is going to call the other tasks in this case. But you can build more complex workflows within tasks now. And that's kind of that's all the code that we did to build our research agent. Actually, it's not that complex. LangGraph makes it pretty easy to build. And now let's maybe try this with remote. So if I go back, oh, actually, sorry, before we go remote, we can actually go ahead and look at what this would look like in a radio app, and then we'll go remote. So I run this local Python app. We'll look at the app code here, I guess, once we look at the app first too. And this is going to spin up a radio app. And I think this should work in code spaces. Open in browser. Okay, good. I've done, again, most of this locally on my computer. So code spaces, wasn't sure. Cool. It gives us a public link that we can navigate to. So here now you have this input box. You could type whatever you want in. I have a few things here as well. Let's actually type something new. Let's say, what is union I haven't tested this, so let's see what it does, if it's good or not. And now it's running locally. It's running that whole task or that agent workflow that we defined locally. And then we'll see, we'll actually deploy this app and deploy the workflow. And this synthesizer report, I won't read the entire thing. Company overview. It says Union AI is dedicated to enabling organizations to effectively build, deploy, and manage large-scale AI, ML workflows and pipelines. Sounds right. If I scroll down, we can see it actually gives a link for the local execution. And again, if I was on a local machine, I could paste this into like my browser and view like this HTML report as an artifact there as well. Okay, now let's go ahead and do this remotely. And then I'll look at the app code if that works for everyone. The app code is just a radio app, nothing too complex in there, but Flyte does make it real easy to pivot between calling a task locally, like that workflow that we define locally, and then also calling it remotely. And we'll see what that looks like. So currently we've been doing everything locally. If you want to set this up on your own cluster, like if you have a Flyte cluster, you would just basically run this command. We're not going to run it today. It should already be there for you for the workshop. But if you had your own dedicated endpoint, you can do that here. Headless, you only need if you're running from something like Colab or GitHub Codespaces. So if you're doing this locally, you can get rid of this part as well. We're going to build our images remotely, and then we'll see in the project, but we can have different domains like development, production, etc., and then different project names. So the one we have today is like LangFeb for the workshop, but you could make different projects inside your UI, which we'll see here shortly. And then you would just set this up there. And then this is how you would create a secret to be logged remotely as well. So once you're set up on your cluster, you say Flyte create secret, give it a name here, and then paste in an input. And then this will be a remote stored secret that you can call into your workflows that you're running remote. So let's copy this in. And now I'm going to go ahead and clear my terminal again. This should run that same workflow, but now on a remote execution. So you need to sign in. I'm going to go ahead and command click on that, hit open, hit next. And then I've already logged in here. And this is, if this is your first time running, if you were here at the beginning, I'd mentioned if you signed up on Luma, the email that you used should be able to access this cluster, but you might have to go through a few questions to set up the login. And if we didn't have our image already built, it would build it first and then give us this run. But this image is already built because I ran this previously. Let's go ahead and click on this. We can see it's spinning up a container here. It might take a little bit for the first time because all the compute is spun down. Once we have it warm, it should be very quick for us to run here. While this is spinning up too, let's see, was there anything else I wanted to go through? We can look at the app code while that's spinning up and running. And this is going to be our Gradio app for that research agent. And I think I already closed it out, or no, yeah. So we had an input box. You could change the different subtopics here, and then you hit research, and then you get the information. All right, cool. We're running here. I'll go back to the app here once this is done running. So we can see inside the UI, off to the side, this is kind of mirroring a little bit like what we saw in the TUI. And I can click into each of these, and I can see what the output is and what the input is for that task. And we can actually see in this case, it wrote it to cache as well. So if we rerun this, it shouldn't do that planning phase again. It should be able to, or sorry, I think this actually read from cache because I ran it before. So it didn't do that planning phase. It actually says it took 0 seconds because it didn't have to do anything. So it already took that pre-existing plan that the LLM had, which again, could be a costly thing for tokens. It's not really a big plan today, but if you were doing something more complex, that could be something that's really useful for you to kind of save and use the cache to use that pre-computed part. Then we have our research agent now is running here. So we look at this agent state, the first state of it. By default, you'll get this kind of view. You can also go look directly at like what the JSON looks like here. This was our output here. And this is the input. This is the research topic. And then this is that node state from LangGraph, where basically it says tools are n because we have a pretty simple graph like we saw. And it says tools. So it's going to go to the next step where now it's calling that web search tool. This was the output, basically what the search from Tavily provided. And this was the input for the Tavily search. So did that twice here. And then we have the agent state again, and then should continue. We can see end, and then exits out of this kind of react, reasoning, and action loop for that first agent. And we see some of the other agents did the same thing, but they actually decided to search a few more times before they exited. This first one only did 2. This other one did 2. This one did 4. And then like you could, again, basically adjust that value. So if you want to do way more research and really reason about it, you could do that. And then we have our synthesized report. And again, you get the output here, but let's go and look at this report section. And this is kind of the nice HTML report that we have. And so this is logged. Every time you do a run like this in Union, this is all versioned and all snapshotted. So all the inputs, outputs are all logged here. So you can always come back, troubleshoot them. It's also really useful for doing things like a lot of people use this for training pipelines. So you always have a snapshot of your hyperparameters. You have a snapshot of the artifacts, like the models. What exact data set did you use? You can go and look at that here. You also get the code. So if you actually want to look at the code, you can pull up in this little window, see the exact code that was ran here. So it makes it really easy to share across teams, like the artifacts, but your whole projects. You can rerun from the UI as well. If we go back to our app code, actually, I'll run the deploy command and then we'll go through this. So now if we want to serve that app that we previously saw, we can just say Flyte deploy app and then serving environment. And this will deploy an app that we'll actually have access to on the web that will call our remote agent in Flyte. So it's building the image here. I guess I didn't run that on this cluster yet. While that's happening, let's go through this remote code, or sorry, the app code. It's pretty simple. We're just creating a serving app environment for using Flyte, kind of like we saw before. So we'd pass in what libraries or container stuff that we want to build here for our app, saying the resources that we want. Again, so just CPU and a little bit of memory here. But again, you could add a GPU. So it makes it really easy to also serve models. What API keys do we want to read in? Does it require auth, false, or true? False means that once this is up on the web, anyone can access it. So you can share it outside of your org. But you can also have true here, which is on by default, so that you could share internally with other people that can log into your Flyte or Union cluster. And that, so it makes it really easy to build like internal tools here. And then we have a run query. This is running with a context mode here. So if you remember when we ran that first part, we passed in local and it ran locally. So it didn't kick off a remote Flyte task. And if we don't have that parameter local, even if we ran it, even if the Gradio app was deployed locally, then we would kick off our remote run on Union. So it makes it really easy for development. Actually, if you already have like your workflow done, but then you're iterating on your Gradio app or whatever app you're developing locally, makes it really easy to test that out. We're passing that research workflow, which is our registered workflow that for our research agent. Pass in the query, the number of topics, max searches, just like we kind of saw before. And then this is some stuff just making sure that like if the report starts with this HTTP, it'll actually render it as a clickable link and then go back to the Union cluster, versus when we had it locally, it was just kind of a grayed out temp link that you can't click on. So it just looks at that link, makes it clickable. We'll see that in a second here when we go look at it. Now this deployed. And then this is just some Gradio code. We have these simple building blocks. They have pre-existing blocks where you can add in like this text part or this slider part or this button or text fields. They just came out with a new thing called HTML, Gradio.html. So instead of those building blocks, you can actually render like any HTML in there now, which is really cool. And then we're just going to launch it on a server port. And then if we ran that remotely now, so if you go back to your cluster here, hopefully you're able to log in if you were following along, and you hit this little app button off to the side, you can see that we have this research agent UI. And I'm going to click on this. It looks deployed. It's active. Again, the default, I think, is it spins down to 0. So it's going to take a second to spin up here. A parameter that I didn't have there that I should add is you can actually say like how long will this stay up and what's the default. So like you could have minimum of 1, so there'd always be one of these up, and then it could scale up to multiple ones depending on how many people are visiting it. But by default, it scales down to 0. So it'll save you compute and cost, but then it will spin back up when you and when someone visits the page, and it'll just have some spin up time. So here now, this is actually deployed on the web, and I didn't check, but you might be able to access this because it said auth equals false. It should work. So you could try this out, and I'm going to give it one of these research topics. I'll say compare vector databases, Pinecone versus Weaviate and Chroma. Let's hit search here. I'll use these default number of topics. And now we can see it's kicking off a run. It says running on Flyte. We can click this button and it'll open up. And now it's going to kick off our agent run here. And then once that's done, it'll render the HTML back in here. And there's some other stuff maybe we could talk about, but that's basically all the code I think that we created today to create this whole kind of system that we have going on here. And I don't think we've deployed it yet, but we have some stuff coming around really fast container start times. This is already pretty fast. Like I was saying, all this compute spun down. Once it's hot or warmer, this will go incredibly fast. So I'll actually show you after this runs. We'll hit rerun and you'll see how fast it is. But what do people think? Or did you learn something new? Was this interesting? Are you going to use any of the things that you learned today? So that's going. Let's try and give it another topic actually while that's even running. Actually, no, because we want to get the return value here. It'll probably mess it up. If you were following along or you're following along later, you went through and built an agent using some of the state-of-the-art, like it might feel relatively simple, but it's some of the state-of-the-art tools are in the space. Like Tavily is huge in the search area. Actually, they just got bought by Nebius. So they're really betting on. So see how fast that is now that we have the container warm. It's pretty much instant. And if we went back to our area, we could see that it gives us our report here. Yeah, so we use like state-of-the-art tools. LangGraph, one of the more popular open source agent frameworks out there for abstracting away some of the agent conventions. And then Tavily, popular in the search area for connecting agents to the web. And then Flyte and Flyte 2. Flyte's used by like thousands of companies in production today for like training models. And then people are adopting 2, which is new, for building agents as well in production. And then we saw some cool stuff too, like the local development side of Flyte, I think is really interesting. We go back to the TUI. I love the TUI. We get that cool kind of output structure here that I find really useful. Again, like I was saying, if you're using really complex agent workflows, this is really useful. And the caching is nice also, not just for agents, but if you're doing data pipelines or ML pipelines, you could cache your downloading data, pre-processing steps, and the caching works locally as well. And the reports work locally. Like I said, I just can't, I don't think I can open them in the VS Code because they're temp file in the system, and then they're just rendered as HTML, but you get those HTML graphs like we saw. So this is also useful for, PyTorch pipelines, and you want to have your training and loss values kind of logged here, and you get that lightweight form of experiment management. Right, what do people think? Still see quite a few people here, but the chat has been relatively quiet. So give me something to react to. Well, people are still here because it kind of went through all the code, but if you do want to hang out and go through and talk a little bit more about some of the Flyte stuff. So we already saw this in action. Makes it really easy to program agents, but also other pipelines, just pure Python. So Flyte 1 had kind of a little bit of a domain specific language. like I mentioned, you have tasks and workflows. So you couldn't do pure Python like loops and try catch failures in your workflow, but now you can do that in tasks. Makes it really easy. Still runs on Kubernetes. I guess I don't think I even mentioned that. I totally should have. So Flyte is always deployed on a Kubernetes cluster, and it could be on cloud or on-prem. And then it does that image builder piece that we had seen before too during the walkthrough. So we didn't have to write a Docker container. We just gave it a list of libraries to install from a Debian base image, but you could also add different things like CUDA versions and apt-get to really set up your environment however you want. We kind of already saw this in action, the reports, the I guess the metrics we didn't look at. I don't know if this ran long enough to render them. So they only render, yeah. So if you have GPUs and stuff that is really interesting, you can look at your compute usage versus what you defined. So here we can see that we defined 2 gigabytes and 2 CPUs. I think we could just use one here because it barely uses them because we're mostly just calling it API. So it's really easy. But also it's not that much to call 2 CPUs versus one. But if you were using like a bigger GPU and you looked at the utilization was really low, you could bring that down. And this can ultimately save you quite a bit of cost as well. We saw how to define environments. Makes it really easy. One thing I didn't really talk about, I guess, is with agents, like we use this reuse piece for the one today. And I think a lot of people use this because it's really fast to run agent tasks. But if you want a separate environment with like the GPUs in one of them and only CPUs in the other one, you can define multiple environments and run them across different agents. Also, if you want to do it for isolation reasons, and we actually have some really cool stuff coming up very soon about more on sandboxing. But if you want an agent to not have access to other stuff that's in a container, you can just use this not reuse, or don't use the reuse policy there, and then it'll be pretty isolated in its own container environment there. Like I mentioned, you can host models too. So I think we're seeing more of this in the industry where people are trying out their small language models. And in that case, you want a GPU. So GPU one task, and the other task wouldn't have a GPU. We saw how this works. It's really easy to go from local to remote. Just add that local flag, or don't add it and you will kick off remote. You can also define how this gets kicked off through the Python SDK. So if you want to add like arg parsin to your terminal entry, you could do that. And actually you could have different flags for like remote, development, production, etc. And then it could even read from different config files, which is kind of nice. We saw traces in action. One thing really cool, I kind of mentioned it, but I'll go a little bit further again if there's no other questions in the chat. But feel free to start asking questions. I'll be hanging out longer. So out of the box retries for durability, we didn't see any failures today. And it's kind of maybe hard to see on my screen share here, but you can see that this is trying to call like a web API, and it failed like 3 times. So this happens a lot if you're doing like rate limits or API failures, you might hit a rate limit or an API failure, and you just often need to retry it. And so out of the box task environment will retry something 3 times. But you can overwrite this. So you can do like 5 or more if you have a finicky API. And it's really nice because you gracefully recover without losing state. So if you did like this whole, like this is actually an example from like the web search kind of thing here. But if you did like a whole bunch of planning and you had all these other sub agents do something, and then further down this chain, you have a failure, that's going to suck if you have to redo everything. Because one, you're paying for all those tokens, but also quite a bit of time. If this is like something with a direct user, that can obviously make them not want to use it. So it doesn't lose that state, and it'll just retry it. And then something really cool is this error handling and dynamic recovery. So this is what I was kind of mentioning before at the beginning, how you could overwrite your infrastructure. So we saw in Flyte, it's really easy to define that, you say GPU, this much memory, etc. You can actually catch these errors like a memory error, and then have the agent rerun overwriting its infrastructure. So here, this has an out of memory error, and then it recovers from it. And how that happens is basically we look for this out of memory error, and then we'll overwrite the resources here with this 1 gigabyte of memory, because originally it just had 250 gigabytes memory. But when it gets that out of memory error here, then I'll retry it with this much memory. And you could have like a list or something like that for it to run through. And then have a stopping point as well, so it doesn't get too crazy if you don't want it to. We can actually have like agents now build their infrastructure with Flyte, which is cool. Flyte's also, as you saw, pretty easy to write. Once you just have like that environment defined, you're just adding like decorators above functions, which, if it's easy for you to write, also means it's very easy for coding agents to write, like Claude and more. So if you're interested too, you should try having like your agent write something in Flyte, and now it has access to this production grade infrastructure, basically, which is really nice. And we've done some experiments with like an MCP server with it, though I think we'll be talking more about in the future. But yeah, it basically gives agents the ability to run things at a production grade scale across and be able to fan out and scale up compute really, really easy. All right, I'm going to ask again, what do people think of the TUI? Because it's a new feature. It's actually my first time showing it off to a bunch of people at once. Would it be something that like you're interested like in using? Again, you can just pip install the Flyte SDK here with like bracket TUI to get also install textual right now. And you can get this right out of the box without having to sign up for anything or connect to a Flyte cluster or set up Kubernetes or Docker or anything like that. You just get this and the caching and the local reports out of the box. So it's like a really lightweight little local orchestration system now that you can come back and look at all of your runs. I've been using it a lot for local development now, and I really like it, but I also, I work on it. So I'm curious what other people think of that haven't used it before. Is it something that you think is interesting that you would check out using for just even local development, even if you're not going to connect to like a Flyte or a Union cluster? And I haven't, again, see quite a few people still here, but no questions in the chat yet. So I'll probably end the stream soon if there's no questions. But I will share again also the Slack link. So if you have questions later, find me in the Slack community and ask them. Or you can connect with me on LinkedIn if you want as well. And I'll hang out for a couple more minutes. Also, so if you do want a remote cluster, like I mentioned, the Flyte 2 backend isn't open quite yet, even though the SDK is. The SDK, you get all those kind of local features that we saw today. But if you do want to try out a cluster for your company, you can sign up for the beta here. And we always like hearing feedback on Flyte 2. So far, the feedback is that people love it. But if there's any bugs or anything like that, it's always great to have people raise them. Any other questions? Any last thoughts? Doesn't seem like it. All right, I'm going to wrap up the stream. Thank you for coming, everyone. I would love to hear your feedback later. If you have any questions on using the TUI or a Flyte cluster or anything like that, let me know, again, in the Slack channel or on LinkedIn. But for now, I'm going to end the stream. Hopefully, I will talk to some of you all at some other events. I will be at NVIDIA GDC if anyone's going there in March. I'm really excited to be back. It's always a really, really fun event. If you're going to be there, let me know if you want to get coffee or something like that. Right. Bye.